Unit 9, we're going to talk about logarithms. But before we start up talking about logarithms, I want to devote one day to these things called inverses. I don't think we've talked about that yet. So let's talk about inverses here for a second. Before we do, I want to give you guys a little warm-up question here, and I want you guys to complete the table. So, hold on, un momento, please. Yes, you write this down. So I want you to complete the table, and then I want you guys to graph your function there just by plotting the dots and connecting them, okay? And then I'm going to give you another one to do. And this may seem stupid, but bear with me. There's a reason for it. It's more like something to kind of exactly. Thank you. Yes. Da, 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 da. Bro, you're talking about heaven on earth. He's so weird, dude. That guy's really made an influence on you.
That's why you and your family be home. I'll be going to church today.
All right. I'd like you guys to do that one as well. So complete the table, plot the dots, connect the dots to make your graph. And matter of fact, when you guys do this, I wonder. I'll tell you. What I'd like you guys to do is I want you to put them on the same graph, okay? Put them on the same graph. Don't draw two separate graphs, just one x, y axis. So you have one graph with two lines on it, basically, right? We're going to be, yeah, there's a comparison happening there, yeah. Woo. That worked out interestingly. I don't want that color. I want a different color. Okay, so now, what do you guys notice comparing these two tables? Anybody notice something interesting in comparing the two tables there? What do you notice, Chris?
They kind of have the same mechanisms, but
Good. All right. Guys, let's see. Henry and Nelson. I'm teaching right now. So just a minute. So Chris made an observation. Henry, you're still not on board. Necesito que yo hablo en español para entenderlo. Okay. We're good? I can just say it in English, right? We're good? I just want to make sure. I said it once. It seemed to make sense. Okay. So Chris made an observation here. He noticed that the tables are the same, but they're reversed. You guys see those numbers, how they're the same thing, but they're just reversed? Okay. That's what an inverse function are. These two functions, these two equations are inverses of each other. They're opposites. So what makes an inverse function an inverse function is where all the x's for this one are the y's for this one, and vice versa. Okay? So that's what inverse functions are. And another interesting thing is that inverse functions, when you graph them on the same graph, they have this appearance to them. They always look like they've been reflected through this diagonal line going straight down the middle. Kind of like if you were to take a piece of paper, right, and paint one and fold it and open it up, it would just copy it literally across from there. So yeah, it's like flipping over that diagonal line there. That's what inverse functions always look like. And the reason for that is because the x becomes the y and the y becomes the x. So it's like you just flipped the x's and y's around. Yeah. Well, they would keep going, so they would cross and make an x eventually, right? All right, so that's that. So let's go ahead and start off with our part A here, which is What is an inverse function? All right. Henry,
Yes.
are you writing while you're talking?
I'm not turning around like when I talk to him. I look forward. Wait, is this recording?
Yeah.
Say my name.
Using a little bit of a different notation this time. I think earlier this year, I'll come back to that. But do you guys, I said I'd go back just a minute. Do you guys remember this?
Yeah.
Okay. So that's just, if I write this, you guys agree that's just the same thing as saying this, right? Okay. But the reason why we do this is because it names the equation. So this equation's name is f, okay? And why do you want to name an equation? Just because maybe you're talking about more than one equation at a time. You have a way to name them. So now, like if I want to talk about another function over here, g, I could say, well, this is equation g and this is equation f. The other thing, the reason they put the x here is because in function notation, that's basically just telling you what number you're plugging in for. So x is my input, and then the answer that we get out is our output. So like on our warm-up today, we did this, right? We were plugging in these numbers, and we got out these numbers, inputs and outputs. So what is an inverse? Two functions, the names of the functions I just randomly chose are f, g, and f. I'm going to say these two functions are inverses of each other. And here's what makes two functions inverses. With g, if you plug in a and you get b, f is an inverse of that if you plug in b and you get a. Okay? And that's kind of like what we saw in our warm-up today, right? We plugged in -2 to this one here. We plugged in -2 and we got 2. And over here, if you plug in 2, we got -2. So the input and the output are swapped, in other words. So that's what makes a function an inverse. Now we'll talk about something else here. They have special notation for inverses. So let's talk about the notation for inverses real quick here. So notation for inverses. Notation for inverses. If f of x is the inverse of g of x, then instead of f of x, we can write this. Okay. I'll pause there while you guys are writing. All right, so John was saying he felt a little confused, and Henry gave me the, well, he didn't say it, but he had it in his heart. He had in his heart the, what the? All right, so we have the g with a little -1 here. So if two functions are inverses, f and g, say those are inverses of each other, instead of using f then to name that function, we're going to call it this instead. And that way we know, oh, this is not just another function. This function is actually the inverse of g. They're opposites. Okay? So that's what I mean by that. And I think what's unfortunate about this notation is it kind of looks like an exponent, doesn't it?
Yep.
But it's not. That is not an exponent. You might be tempted to think that means this, right? Don't you guys remember, what do negative exponents do? Yeah, they put it in the bottom. So you might be tempted to think that. That is not what that means at all.
So we don't write that?
No, don't write that. So all that means is that it's the inverse of G. Okay? So it's a writing thing. It's a language thing. It's arbitrary. Somebody decided this is how we're going to write it, and that's the idea. So there's no math there. It's just a name. All right? So now that we know how to do the notation, one last note before we actually get into our math for the day, because this is just an introduction stuff. So let's talk about the graphs of inverses real quick. We're not going to really do much with this, but it's a nice little fact to be aware of. I might refer back to it once in a while. As we mentioned to you guys, inverses are if you graph them on the same axis, they look like it's the same graph, but it's just been reflected through that dotted line. So if I drew this,
We're writing this, right?
does somebody think they could draw what that might look like? What the inverse might look like?
Yeah.
Who's got a really artsy brain here? Could you imagine? You want to come try it?
Yeah.
That was Rowan I was talking to. I'm gonna give her a shot. But if she can't do it, I'll let you try. It's hard. You have to imagine, like how I like to imagine,
Just my
like
finger?
yeah. I
Alright.
like to imagine like you painted that line, you folded the paper on the diagonal line, you open it up.
Right.
I think she nailed it. I think that's a really good reflection.
I
So,
don't
now
high five.
to be more specific, I would make so just so you know, Rowan, I give you 100% for this. This is great. However, to be a little bit more specific, do you see how this one has an asymptote right here?
Yeah.
So this one will look a little bit more like that, because its asymptote will be vertical instead of horizontal.
Yeah.
Now,
That already was gonna hurt my brain.
do you guys remember last chapter talked about exponential functions? This one is an exponential function right here. Okay? We're learning about logarithms. Logarithms are the inverses of exponential functions. So when we get to graphing logarithms, they're going to look like this one down here. Okay? We'll get to that later though. But that's the graph of inverses. What they are is they are a reflection through the line this dotted line is the equation of that line is y equals x. Okay? So we'll call this one g of x. If I call this one g of x, what am I going to call this one, you guys? G with that little negative 1, right? G with a little negative 1. Now, I could have called the bottom one g and the other one g negative 1. It doesn't really matter. So, like, let's say I have a brother, right? I could say he's my brother, or he could say about me, he's my brother, right? Same thing. So this guy could say he's my inverse, or this guy could say he's my inverse. It doesn't really matter which one you call the negative 1, technically. All right. So now, what are you guys going to be expected to do on your homework? We're going to actually get into the problems now. So what I'm going to ask you guys to do is I'm going to give you an equation. Did you guys notice how, like, on our warm-up today, I gave you 2 equations? How did I pick those 2 equations? How did I know what to pick so that they would actually work out like that?
Like 2x and 6.
Because one was a multiplication, one was a
Good
division.
job. So you guys are already seeing it. There's a lot of opposites going on there, right? Instead of plus 6, it was minus 6. Instead of multiplication by 2, it was dividing by 2. So that's the idea. So I'm going to give you guys some steps for this, and then we're going to do a couple of practice problems, okay? So here we go. What am I on? D? Okay. How to find an inverse. How to find an inverse. Okay, here's your steps. This is the main thing you need for today in order to be able to do your homework well. We've laid the foundation of what it is. Now let's talk about it.
It's Friday, mate.
So replace f of x with y. So on your homework, I don't even think they're going to have an f of x. So
So we don't do the homework.
I have a picture yesterday.
we could probably skip that step on your homework, but I'll write it like this for our lesson today. So you're going to have an f of x there. We're just going to get rid of the f of x and we're going to put a y there instead. And the reason we do that is because the f of x is ugly. Okay, and that's really the only reason. It just makes things look really confusing. So, step 2. This is the main step. Switch x and y. Switch x and y. After you switch x and y, we're going to get y by itself. Get y by itself. One more step. We're almost there. I know. You guys ready?
This is the last one?
This is the last step. Replace y with f negative 1 of x. Because by then we've got a new function. We're going to call it the inverse at that point. So, step 1, replace the y with f. Step 2, switch the x and y. That's what makes it an inverse, because the input becomes the output and the output becomes the input. But then, since it's a function, we have to have the y by itself. So that's step 3. And after you've done that, just rewrite it with an f inverse instead of a y and you're good.
So, since you're writing f, like a negative f of x, but with a negative 1 on top, I don't know how you say that.
F inverse of x.
Yeah. But since you're writing with a negative 1 on top, does that mean since it's negative 1 and not like negative a or anything, it's always going to be 1? It's not gonna
Yeah.
be...
Yeah, they won't write it anywhere else. There's nothing. Yeah. All right. So let's do an example problem. Ready?
Wait, we're finally going to actually...
I know. We haven't done anything. We've just been talking all block. I know.
You know, it's right, right?
Find the inverse. All right, so f of x is equal to 3x minus 5. Go ahead and write down example 1. F of x is equal to 3x minus 5. Okay, so what does step 1 say, you guys? Replace f of x with y. Okay? And the only reason we do that is because the f of x is big, clunky, ugly symbol, and it just kind of makes things look more complicated than they need to be. So we put a y there. Now, what's the next step say? So I'm going to put the x here, and I'm going to put the y here. Now that step right there, that's the magic step. That makes this thing automatically an inverse. Because what's an inverse is just where the x is the y and the y is the x. So that did it. But the problem is that for step 3, functions usually have y by itself. So we need to get the y by itself now that we've done that. I'll bring it back, don't worry. Alright. So
That's totally right.
yeah, for step 2. Let's go ahead and do step 3. That's step 2. Let's just switch the x. It's right. It's all here, honey. It's up here. All right. So I want to get y by itself. What would I do first? We would add 5 first, right? That would leave me with x plus 5 over here. 3 over there. Now what? Divide by 3, right? Now this step here, step 3, you guys, that's the one that's going to probably get you guys, because all these other steps, they'll literally be exactly the same every time. Oh, I don't want to box that yet. All these other problems, it's going to be literally the same every time. This one, you just have to know how to get y by itself. Different algebra moves will apply for different problems, but the idea is get y by itself. Yeah? No, it's being added, because 5x means 5 times x, but we're just adding it. Okay, let's do the last step. What's the last step say? Yep. this function is the inverse of the one that we started with.
Like, that's it?
Yeah.
So why did I feel like this was gonna be like possible?
I don't know. All right, your turn.
No, well,
Now, guys, I'm going to use G instead of F. So you know what that means, right? Your answer is not going to be F inverse of X at the end. It's going to be what? G inverse of X, okay? So here's yours. G of X equals 7X minus 2. Go ahead and see if you guys can find the inverse of that function real quick. Make sure you guys are grasping it. So, Henry, would you pick a number between 0 and 5, please?
yeah. 2.
Okay, so Henry chose 2. So I'm going to take this problem up here and I'm going to plug 2 in for X. Let's solve that. You don't need to write this, you guys can just watch. But I plugged in 2 and I got out 12. If I take this one down here, the X plus 2 over 7, and I plug in 12, what do you think I'm going to get? 2. Right? Because for this one, if you plug in 2, you get 12. If this is the inverse, if you plug in 12, you should get 2, and it works. What's 12 plus 2?
14.
Divided by 7? There it is. So we found the inverse. Okay? And I let Henry pick because that would be true no matter what number you chose. It would always work. Okay? All right. So now I want to just do a couple more examples just to kind of show you guys the different algebra moves along the way. But after that, we'll call it quits. Okay? So, yeah. All right. So let me show you one that looks like this. Let's do this. So we'll call this example 2. Ready? F of X equals, let's just do the opposite of what we just did. How about X minus 3 over 8. X minus 3 over 8. Oh, I would write them down because it'll help you with your homework. So step 1, just replace that, right?
Yep.
Step 2, switch the X and Y. And here's where things get different, okay? Here's where things get different. I need to get Y by itself. So to get Y by itself, what I'm going to do is I'm going to multiply both sides by 8. I'm going to write my problem again here. And I'm going to do times 8 times 8. So now on this side on the left we have 8x. And what happens on the right side? They cancel. And from there, I think you guys would know what to do, right?
Yep.
Just add 3 over. So the algebra was a little bit different there. We had to do a little multiplication to make it work for us. Let me show you a third one, and that'll be it for the day.
We didn't finish the other one.
Oh, you're right. We didn't. What did I forget?
We forgot to make it inverse.
You're right. Thank you for pointing that out. So I should put F inverse here, right? Good. Now, once again, on your guys' homework, you don't need to worry about the first step or the last step on the steps I gave you. They just kind of leave everything as Y and X. That's fine. You can leave it like that if you want.
The test, how's it gonna look?
Probably like your homework. I use the same software for both, so. But this is good. I want you to know that notation. So I might have a question, John, about the notation on your test. But, all right. So here we go. The first thing we're going to do is we're going to replace that H with this.
Is this a different color?
Yeah, this one is a little different.
What's this example 3?
Yeah. Now we're going to switch the X and Y. Henry, do you You might need a new seat. You might need to be sitting close to my desk so we can be friends. All right, so replace h of x with y, switch the x and y. Okay, now for this one, you guys, over here we multiplied both sides by 8. Did you guys notice how the whole thing was over 8 though?
Yeah.
Over here, only the 1 is over 3. So the way we're going to handle it's a little bit different. What do you guys think we would do to solve?
Plus 5.
Okay, so we do want to so there's two things you could do. Both you guys are right. Somebody said plus 5. You could do that. And you said what?
Multiply it by 3 over 1.
Good. The thing about the multiplying by 3 over 1 is fine, but you have to remember when you do it to all 3 terms. Now over here, I only did it here because there's only, how many fractions do we have here?
1.
So you only do it once here and once here. Okay? Over here, how many things do I have? I've got 1, 2, I've got 3 things this time. So if you're going to start by multiplying by 3, you have to multiply all 3 of them by 3, the bottom number. So it doesn't really matter what you do first. I think I'm just going to stick with what I've always shown you guys, which is multiplying first. So I think that's what I'm going to do. So I'm going to do, this is how I'll show my work here. I'm going to put that in brackets, and I'm going to put a 3 out here. Yeah. And I'm just going to show my multiplication like this. So what's 3 times x going to give me? 3x. What's 3 times 5? 15. What happens here, though? Which cancels out to just be 1, right? After you get past that step, it's pretty simple. What would I do to get y by itself? Add 15. So there's a few ways you guys could have handled that one. There's not just one way, but you should end up with the same answer.
We're pretty much just distributing 3 in.
Yeah. Yeah, exactly. All right, so I think I'm going to stop there. That should get you through all your homework problems. And then tomorrow, Monday, we'll start hitting up logarithms. That's a whole new world for you guys.
What?
Logarithms.
Oh, what's that? Can you give us an example?
Have you seen this button on your calculator? That's what we're talking about. So.
Oh, no. Mr. Bailey.
Yeah, they actually.
Mr. Bailey.
Here's what I found in algebra 2. People hate logs because it's a whole new thinking system.
I like logs.
In pre-cal, they like them better because they're used to them. But